in order to determine the application name for a given flow so that we can apply the right policy, which bio it should go into, whether it should be permitted or denied, what quality of service, and so on, we need to accurately assign an application name to each flow. And in most cases, we need to do that on the first packet. What it's designed to do is use pipelines like the domain pipeline or the address map pipeline to accurately select the application name on the very first packet. The very first TCP SYN that comes across the network, we need to know what that application name is for that very first packet so that we can steer it the right way. So we've come up with a series of different solutions over the years to optimize this first packet application selection. This quick TOI here is one of those optimizations. So on the left here, we have a Caribbean site. This Caribbean site has 2 users. So here's user 1 and here's user 2. So when this user's Office applications want to connect to mstauth.net, it will first resolve the DNS name. So it will resolve the IP address for this domain here. Then it will connect to that domain. This is fundamentally what the EdgeConnect does that's kind of so interesting. We watch the initial DNS query and the answer come back. We cache the IP address of the public IP address that was resolved in the DNS query. So in this case, we queried for aadcdn.mstauth.net, and the answer that came back from the name server was 152.199.4.44. So we cached that in the local EdgeConnect, in the EdgeConnect itself. So now the EdgeConnect has a high-speed cache of information that maps a domain name to a public IP address. It's very important. This domain name is mapped to this public IP address internally in memory. So what that means is that now that this DNS cache is in the memory, the moment the user's Office application opens a TCP socket to the IP address that it just resolved, we immediately know that, hey, this 10.10.10.4 connected to 152.199.4.44. Therefore, the domain must be aadcdn.mstauth.net, and we know that this domain is mapped to Office 365 Common. So the EdgeConnect uses this, watches the DNS query answers, caches the results, and then uses that cache to appropriately classify subsequent TCP sockets that come through the system. So this is how most of the application names that you see in the orchestrator or in the flow table, those application names are being derived through this domain pipeline. The problem arises when 2 different users, so the second user here, 10.10.10.5, loads up into his browser foo.bar.com, does a name resolution for foo.bar.com, and gets back to the same public IP. The same exact public IP. This is very common. Virtual hosting IPv4 addresses are not unlimited. Every single website you go to doesn't have its own unique public IP. There are, especially Akamai and other popular content delivery networks will have dozens, or I don't know if it's in the 100 range or not, probably, websites per virtual IP address. And this can create problems for us because now you see there's an ambiguity here. So when the second user performs a DNS query, they get back foo.bar.com with the same public IP address. So now we have in our cache here two different domains, let's say with the same public IP. So now the question is, when the second user then goes to connect to the IP address that he just resolved, what application name do we assign to it? Is it mstauth.net or is it foo.bar.com? You notice that we track the source IP address. So that was one of our answers originally, was to track the source IP address plus the domain plus the public IP. And now you can say, well, if I see a source IP of 10.10.10.5 and a domain of and an IP of 152.199.4.44, then we know it's foo.bar.com. You use all 3 pieces of information. the source IP, the domain, and the public IP to create a unique record. But what happens if a single host connects to both mstauth.net and foo.bar.com? My laptop or my one user on the network connects to two different domains or websites on the same public IP. That's the fundamental thing here that's a problem. It's like a first principles problem. There's actually not a direct way to solve this. There's not a real way to solve it, because if both DNS queries are coming from the same private IP on the LAN side of the EdgeConnect, how do we determine which domain we should choose here? Should we choose mstauth.net or should we choose foo.bar.com? When we go to insert the records into the domain cache, we'll do a confidence lookup and say, all right, if I've got foo.bar.com configured with confidence 50, and I've got mstauth.net configured with confidence 75, the system will simply trust the confidence, and mstauth.net will always win. It breaks the tie. It breaks the ambiguity. There are several extra things we did here. So number one, prioritizing domain names in the DNS cache based on confidence value, the thing I've been talking about. We did that. We also will highlight in the flow details when there are multiple domains associated with the single IP. If an application is used in policy, it will take precedent automatically.